This video looks at using a Raspberry Pi 4 to read data from a bn-880 GPS module and display it on a LCD1602 display. The bn-880 includes a 5883 3-axis magnetometer that is used as a compass by using the X and Y magnetic field components to determine the direction it's pointing. The Z-axis magnetic field can give a rough idea of the tilt angle of the module, which would result in an error to the direction. Like the bn-220, the bn-880 GPS uses a serial interface for the GPS data. I couldn't find a detailed data sheet for the bn-880. However, the GPS for the bn-220 uses the same M8030KT chip as the bn-880, so the serial message structures are the same. The GGA message structure is used to read the latitude and longitude from the character string. The I2C bus addresses for the connected devices can be viewed by using the I2C detect command. The first bus or /dev/I2C-1 is probed. It shows two addresses. The 0x27 address corresponds to the PCF8574 chip that provides an I2C interface to the LCD1602 display. The 0x1E address corresponds to the HMC5883L compass. The datasheet for the compass tells us that it has a read address of 0x3D and a write address of 0x3C. The 5883 magnetometer has an I2C interface used to retrieve the data. Honeywell's datasheet for its HMC5883 chip gives detailed instructions on write and read functions for the chip. It uses two 8-bit registers to form the 16-bit data. A C program was written to receive the GGA message structure, locate, and extract the latitude and longitude using the serial interface. Wiring Pi plus Wiring Serial and Wiring Pi I2C were used to provide the functions for working with the interfaces and obtaining the data. Serial Open was used to initialize the serial port /dev/T0 and set the baud rate to 9600. The serial data avail function was used to check for data on the serial bus and learn how many characters. Strings were rejected if they were too short to contain the GGA message structure. The serial data was read one character at a time with the serial getChar function and assigned to a character array. The CSTR-STR function was used to locate GGA in the character array and trims away preceding character in the array. The location of the latitude and longitude in the message structure is then used to copy the data to a small character array element by element. The 5883 code has one function for initialization and one for reading the magnetic field X, Y, and Z magnitudes and calculates the direction of orientation from the X and Y components. The code therefore is used to initialize the magnetometer and read its data over the I2C interface. Wiring Pi I2C functions are used to write and read from the 5883 registers. Data is read from two 8-bit registers to obtain the 16-bit value for each magnetic field component. The X and Y data are used to calculate the direction angle with the ITAN2 function. The Z-axis data could be used to correct the X and Y data when the magnetometer is tilted. For the GPS to function, it needs to receive signals from satellites. If you move to a new environment, it can take up to half an hour to lock onto good satellite signals. If you are in an indoor environment, you may need to place the GPS by a window to receive satellite signals. C is used as a programming language to make porting the code to a microcontroller simpler. The motivation is power consumption. A Raspberry Pi 4 power consumption is rated to be between 3.8 Watt to 6 Watt depending upon the computational load. Where ultra-low power microcontrollers are available and have minimal power consumption compared to 250 mW power consumption of the bn-880 GPS and 500 mW to 1 watt power consumption of the PCF8574 I2C module. For now, the C code is run on a Raspberry Pi 4. The program reads the data sequentially, processes the data to have the desired formats as character strings, then writes the data strings to the 16:2 LCD display. The data is cleared after displaying the data for 5 seconds. Since I am shy, part of the latitude and longitude values have been deliberately blocked out to conceal my location. A single executable file results from compiling the C program. When porting the code to a microcontroller, appropriate UART and I2C drivers will be needed.